Have you ever wondered how a civilization, thousands of years ago, managed to build monuments so vast they can be seen from space? The Great Pyramid of Giza stands as a silent testament to human ingenuity, a colossal riddle baked in the Egyptian sun. For over 4,500 years it has guarded its secrets. It was the tallest man-made structure on Earth for an astonishing 3,800 years. Imagine that. For nearly 4 millennia, nothing built by human hands surpassed its height. This single fact alone is enough to make you stop and think. What did the ancient Egyptians know that we have perhaps forgotten? This question is the starting point of our journey. These monumental tombs were not just piles of stone. They were complex, precisely engineered structures. They were designed to last for eternity, and in many ways they have succeeded. The sheer scale is difficult to comprehend. The Great Pyramid alone is made of an estimated 2.3 million stone blocks, some weighing as much as 80 tons. That's the equivalent of 12 modern-day elephants. How did they lift such incredible weights to such dizzying heights? How did they achieve near-perfect alignment with the stars? These are not simple questions, and the answers are far from straightforward. They represent some of the greatest mysteries in all of human history. The pyramids were more than just buildings. They were a statement. They were a declaration of power, a bridge to the heavens, and a machine for resurrection. Each block, each chamber, each narrow passageway was imbued with deep religious and cultural meaning. For the pharaohs who commissioned them, these were their stairways to the afterlife, ensuring their eternal survival among the gods. Understanding the pyramids means looking beyond the stones and into the minds of the people who conceived them. It's a quest to understand their beliefs, their society, and their incredible ambition to conquer death itself. As we stand here today in 2026 with all our advanced technology, we still struggle to fully comprehend their achievement. Modern engineers and historians continue to debate the exact methods used. Theories range from long, straight ramps to winding, corkscrew-like ramps around the pyramid's exterior. Some even propose ingenious systems of internal ramps and water-based counterweights. The truth is, we don't know for sure. The ancient Egyptians left behind no definitive blueprints, no instruction manuals for building a pyramid. They left us with the stunning result and the enduring mystery of how they did it. Before a single block of stone was ever cut, the pyramids existed as a grand vision in the minds of their architects. These were not random constructions. They were meticulously planned projects requiring immense mathematical and engineering knowledge. The role of the architect or overseer of all the king's works was one of the most important in the kingdom. Figures like Imhotep, who designed the first step pyramid for King Djoser, were revered as geniuses. They had to be masters of logistics, geometry, and astronomy. They had to create a design that was not only stable and monumental, but also perfectly aligned with their complex religious beliefs. The precision of the design is simply staggering. The base of the Great Pyramid, for example, is an almost perfect square. Its 4 sides, each measuring around 230 meters, have a maximum difference in length of just a few centimeters. Think about that. Over the length of 2 football fields, the error is less than the width of your hand. Furthermore, the sides are aligned almost perfectly with the 4 cardinal points of the compass: north, south, east, and west. This level of accuracy, achieved without modern surveying equipment, lasers, or GPS, is a testament to their sophisticated understanding of geometry and astronomy. How did they achieve this? Scholars believe the Egyptians used simple but effective tools. They likely used wooden stakes and long ropes to lay out the straight lines of the base. To find true north, they would have observed the stars. One popular theory suggests they tracked the rising and setting of a single star and then bisected the angle to find a perfect north-south line. This method known as the circumpolar star method, could have yielded the incredible accuracy we see today. It shows a deep connection between their earthly constructions and their observations of the heavens above. The internal design was just as complex. The pyramids contain a network of passages, chambers, and shafts, each with a specific purpose. There's the king's chamber, the queen's chamber, and the grand gallery, a magnificent ascending corridor. These were not just empty spaces. They were designed to protect the pharaoh's body and his treasures, and to guide his soul on its journey to the afterlife. The architects had to solve immense structural challenges, such as how to roof the king's chamber with massive granite beams weighing dozens of tons. Their solution, a series of 5 stress-relieving chambers above it, was an engineering marvel. Once the blueprint was set, the colossal task of sourcing the materials began. The main body of the pyramids, like the one at Giza, was constructed from millions of limestone blocks. These were quarried from sites relatively close to the construction zone, such as the Giza Plateau itself. But for the outer casing and the internal chambers, more precious stones were required. Fine, white Tura limestone was brought from quarries across the Nile to give the pyramids a smooth, gleaming finish. Imagine how they must have shone in the bright Egyptian sun, like giant, polished jewels. This outer casing is now mostly gone, stripped away over millennia for other building projects. The real challenge came from the granite. This incredibly hard stone, used for the sarcophagi and the lining of the most important chambers, had to be quarried from Aswan, more than 800 kilometers to the south. Getting this stone was a monumental undertaking in itself. The Egyptians did not have iron tools. Instead, they used harder stones like dolerite to pound the granite and slowly chip it away. They would hammer out trenches around a huge block, a process that must have taken an immense amount of time and grueling physical labor. Another clever technique they employed involved using wood and water. Workers would cut small slots into the granite and hammer in wooden wedges. They would then soak these wedges with water. As the wood absorbed the water, it would expand with incredible force, eventually cracking the massive block of granite away from the rock face. It was a brilliant application of natural principles to solve a huge engineering problem. It shows a deep understanding of materials and physics, all achieved through observation and experimentation. It's low-tech, but incredibly effective when applied on a massive scale. The evidence of this backbreaking work can still be seen today at the ancient quarries. At Aswan, you can visit the unfinished obelisk, a gigantic single piece of granite that cracked before it could be fully extracted. It weighs an estimated 1,200 tons. If it had been completed, it would have been the single heaviest piece of stone the Egyptians ever moved. It lies there still, a silent monument to the incredible ambition of the pharaohs and the immense labor required to realize their visions. It reminds us that for every magnificent pyramid, there was a quarry filled with dust, sweat, and tireless human effort. Extracting the stone was only the first part of the problem. The next, and perhaps even greater challenge, was transporting these colossal blocks to the pyramid site. Remember, the granite came from Aswan, 800 kilometers away. The limestone for the casing came from Tura, on the other side of the Nile. How did they move multi-ton blocks across such vast distances? The answer lies in the lifeblood of Egypt, the River Nile. The Egyptians were master boat builders and navigators. They constructed huge wooden barges specifically designed to carry immense weights. These barges would be loaded with the stone blocks during the annual inundation when the Nile flooded its banks. This was a crucial part of the process. The floodwaters brought the river much closer to the quarries and the pyramid sites, dramatically shortening the distance the blocks had to be dragged over land. Special canals and harbors were dug to bring the barges as close as possible to the Giza Plateau. It was a massive, coordinated logistical operation, timed perfectly with the rhythms of nature. The entire kingdom's resources would have been mobilized for this national project. Once the blocks arrived near the construction site, they still had to be moved over land to the base of the pyramid. Again, the Egyptians did not have wheels for this purpose. Instead, they used large wooden sledges. We know this from ancient tomb paintings that depict exactly this process. A famous relief from the tomb of Jehotiotep shows a colossal statue being pulled on a sledge by nearly 200 men. To make the process easier, it appears a worker is pouring water onto the sand in front of the sledge. For a long time, this was thought to be a purely ceremonial act. However, a few years ago, physicists from the University of Amsterdam decided to test this theory. They discovered that wetting the sand in front of a sledge reduces the friction by a significant amount. The right amount of water makes the sand stiff, preventing it from piling up in front of the sledge and making it much easier to pull. This small detail in an ancient painting revealed a sophisticated and clever trick that made the impossible task of moving mountains of stone possible. It is a perfect example of how modern science can help us unlock ancient secrets, revealing a level of practical knowledge that is truly impressive. So the blocks are quarried and transported to the site. Now for the biggest question of all, how did they get them up the pyramid? Lifting an 80-ton block of granite to a height of over 60 meters is a challenge even for modern cranes. The ancient Egyptians, without such technology, must have used ramps. This much is widely agreed upon by archaeologists and engineers. The problem is, no one is quite sure what kind of ramp they used. The ancient Greeks, writing centuries later, mentioned machines, but the primary method was almost certainly a ramp system. The most straightforward theory is a long, straight ramp, extending from the base of the pyramid outwards into the desert. The problem with this idea is one of scale. To maintain a gentle, manageable slope, the ramp would have to be incredibly long. For the Great Pyramid, a ramp reaching the top might have needed to be over a mile long. It would have contained a volume of material almost as large as the pyramid itself. Building and then dismantling such a ramp would have been a monumental project in its own right, and there is little archaeological evidence for such a massive structure. This has led to other theories. One popular idea is that of a zigzag or switchback ramp built onto one face of the pyramid. This would have been shorter and used less material, but would have presented huge problems for maneuvering the massive blocks around the tight corners. Imagine trying to turn a 10-meter-long block of stone on a narrow ledge hundreds of feet in the air. It seems incredibly difficult and dangerous. The logistics of turning these giant blocks would have been a nightmare for the ancient engineers to solve. A more recent and compelling theory, proposed by French architect Jean-Pierre Houdin, suggests the use of an internal ramp. In this model, an external ramp was used to build the lower third of the pyramid. After that, the builders constructed a spiral ramp inside the pyramid itself, just behind the outer walls, to haul the blocks to the top. This would explain the lack of evidence for a large external ramp and would have been a much more efficient use of material. Houdin even points to certain anomalies in scans of the pyramid that could be evidence of this internal tunnel. This theory remains debated, but it shows how the mystery continues to inspire new and ingenious ideas. For centuries, a popular myth has surrounded the pyramids that they were built by a huge army of slaves, brutally whipped and worked to death under the orders of a tyrannical pharaoh. This dramatic image, popularized by Hollywood films and old stories, is a powerful one. It speaks of oppression and the immense human cost of these ancient wonders. However, modern archaeological evidence paints a very different and far more interesting picture. The pyramids were not built by slaves. They were built by skilled Egyptian workers. How do we know this? The answer comes from the sand itself. Near the pyramids, archaeologists have excavated the remains of a large, well-organized village. This was the home of the pyramid builders. They have found bakeries capable of producing thousands of loaves of bread every day. and evidence of large quantities of fish and cattle bones. This shows that the workers were well fed with a protein-rich diet, not the rations of a slave. They were provided for by the state. This was a national project, and the workforce was a valued resource. Furthermore, tombs belonging to the pyramid builders have been found right next to the Pyramid of the King. This is a great honor. Slaves would not have been buried in such a prestigious location. The inscriptions found in these tombs refer to the workers with titles like the craftsmen and the masons. They also mention teams of workers with names like the drunkards of Menkaure or the friends of Khufu. This suggests a sense of camaraderie and pride in their work, not the misery of forced labor. They were organized, skilled, and respected members of society. So who were these people? They were likely farmers. During the months of the Nile's annual flood, when their fields were underwater and could not be worked, they would be called up for national service. This system, known as a corvée, meant that they paid their taxes not in money but in labor. They would work on the pharaohs' great construction projects, the pyramids, temples, and canals. It was an organized, seasonal workforce of Egyptian citizens working for their god-king and for the glory and stability of their entire civilization. They were building their connection to the gods and ensuring the prosperity of their nation. Why go to all this trouble? Why build these mountains of stone? Well, the answer lies at the very heart of ancient Egyptian religion: the belief in the afterlife. The pyramids were not just tombs, they were, in a sense, resurrection machines. They were designed to protect the pharaoh's body and soul, and to ensure his successful journey into the next world, where he would join the gods. The entire structure was a carefully constructed vehicle for eternity. The Egyptians believed that to be reborn, the pharaoh's physical body had to be preserved through mummification, and his spirit, or ka, needed a home to return to. Deep inside the Great Pyramid lies the king's chamber. This is the final resting place of the pharaoh Khufu. Reaching it is a journey in itself through narrow ascending passages and up the magnificent Grand Gallery. The chamber itself is a simple rectangular room lined entirely with massive blocks of red granite from Aswan. Inside sits a large granite sarcophagus, now empty. It's actually slightly larger than the entrance to the chamber, which means it must have been placed there during construction, with the pyramid literally being built around it. The location and materials were all deeply symbolic. The chamber is located in the very heart of the pyramid, a place of immense pressure and stability. The use of indestructible granite was meant to protect the king's body for eternity. The Egyptians believed that the pharaoh, after death, would journey through the underworld before being reborn in the east with the rising sun. The pyramid was the starting point for this cosmic journey. It was a magical vessel designed to launch the king's soul towards the imperishable stars in the northern sky. Interestingly, two narrow shafts, just about 20 centimeters wide, lead out from the king's chamber and point upwards through the pyramid to the outside. For a long time, they were thought to be for ventilation, but this makes little sense, as they were sealed at both ends. The current belief is that they had a religious purpose. One shaft points towards the constellation of Orion, which the Egyptians associated with the god Osiris, the king of the underworld. The other points towards the circumpolar stars, which never set. These were star shafts, designed to guide the pharaoh's soul directly to its divine destination among the gods. The pyramids are not just impressive feats of engineering, they're also masterpieces of ancient astronomy. Their alignment both on the ground and with the heavens reveals a deep and sophisticated knowledge of the sky. As we've seen, the base of the Great Pyramid is aligned to the 4 cardinal directions with astonishing accuracy. This was no accident. For the Egyptians, the cardinal points had deep religious significance, and this precise alignment connected the pyramid to the cosmic order of the universe. It grounded the structure in both time and space. This celestial connection goes much further. The layout of the three main pyramids at Giza, those of Khufu, Khafra and Menkaure, has long fascinated observers. They are not in a perfectly straight line. The third and smallest pyramid, Menkaure's, is slightly offset from the diagonal line formed by the other two. In the 1980s, author Robert Bauval proposed a stunning theory to explain this. He suggested that the layout of the three Giza pyramids on the ground is a deliberate mirror image of the three stars that form the belt of the constellation Orion. The Orion correlation theory suggests that the Egyptians saw Orion as the celestial form of their god Osiris. By building the pyramids to mimic his stars on the ground, they were creating a powerful connection between heaven and earth. The theory even suggests that the River Nile represents the Milky Way galaxy in this celestial map. While this theory is debated by many mainstream Egyptologists, it captures the imagination because it speaks to the scale of the Egyptians' cosmic thinking. Whether intentional or not, the resemblance is striking and adds another layer of mystery to the Giza Plateau. The astronomical precision wasn't just about alignment, it was also about timekeeping. The pyramids and their surrounding temples acted as massive sundials, allowing the Egyptians to track the seasons and determine the precise time of the solstices and equinoxes. This was crucial for their agricultural society, which depended on the predictable rhythms of the Nile's flood. The sun's shadow falling on specific points would have marked important festival days. The pyramids were therefore not static monuments, but dynamic instruments, interacting with the sun and stars to order their world. They were clocks, calendars and cathedrals, all rolled into one. For 4,500 years, the pyramids have stood against the forces of nature and the tides of human history. They've seen empires rise and fall, languages born and forgotten, and religions come and go. Today, they remain the most iconic symbols of ancient Egypt and are arguably the most famous ancient monuments in the world. They attract millions of visitors each year, people who come from every corner of the globe to stand in their shadow and marvel at their sheer scale and antiquity. They are a direct physical link to a distant past that continues to fascinate and inspire us. However, the pyramids we see today are not quite as their builders intended. The Great Pyramid, for instance, was originally covered in a casing of smooth, highly polished white limestone. It would have gleamed in the sunlight, a brilliant white beacon in the desert. At its very top was a capstone, possibly made of gold or electrum, that would have caught the first and last rays of the sun. Most of this casing was stripped away in the Middle Ages to build mosques and fortresses in nearby Cairo. Only a few of these casing stones remain at the base of the pyramid, giving us a hint of its former glory. The legacy of the pyramids extends far beyond tourism. They've had a profound impact on human culture. From the ancient Greeks who named them one of the seven wonders of the world, to modern architects who study their structural stability, the pyramids have been a source of inspiration and knowledge. The quest to understand them has driven developments in archaeology, engineering, and history. The very word pyramid has entered our language to describe any structure with a similar shape, from corporate hierarchies to food guides. Their form is universally recognized as a symbol of endurance and power. In our modern world of skyscrapers and digital technology, the pyramids serve as a powerful reminder of what humans can achieve with simple tools and a powerful unifying vision. They challenge our modern sense of superiority. They force us to ask how a society without computers, steel, or complex machinery could create something so massive, so precise, and so enduring. They stand as a testament to the power of human cooperation, ingenuity, and the enduring desire to leave a mark on the world, to build something that will outlast us all and speak to future generations across the millennia. You might think that after centuries of study, we would have uncovered all the secrets of the pyramids, but that is far from the truth. The Giza Plateau is still an active site of discovery, and new technologies are allowing us to probe the pyramids in ways that were previously unimaginable. We're still finding new clues that challenge our understanding and open up new mysteries. The quest for knowledge is far from over. In many ways, it's just beginning. The pyramids have not given up all their secrets yet. In recent years, an international project called Scan Pyramids has been using advanced, non-invasive technology to look inside the monuments. They use techniques like Moore tomography, which uses cosmic particles to detect voids, infrared thermography, and three-dimensional reconstruction. In 2017, this project announced a stunning discovery, a huge, previously unknown void inside the Great Pyramid. Located above the Grand Gallery, this void is at least 30 meters long, with a similar cross-section to the gallery itself. Its purpose is a complete mystery. Is it a hidden chamber, a structural feature, another construction ramp? No one knows. This discovery is incredibly exciting. It proves that even the most studied monument on Earth still has major surprises in store. It's reignited the debate about the pyramid's construction and internal structure. The possibility of finding an undiscovered chamber, perhaps one containing intact artifacts or inscriptions, is a tantalizing prospect for archaeologists. The search is now on for a way to investigate this void without damaging the pyramid, perhaps by drilling a tiny hole and inserting a robotic camera. The next great discovery could be just around the corner. The pyramids are a gift that keeps on giving. They are the ultimate cold case, a 4,500-year-old mystery that continues to challenge and inspire us. From the methods of their construction to the secrets that may still lie hidden within their stone walls, they remind us that there's still so much we don't know about our own past. They encourage us to be curious, to ask big questions, and to use all our ingenuity to find the answers. The story of the pyramids is the story of human ambition, and it's a story that is still being written. I encourage you to learn more, to visit if you can, and to keep asking questions. If you enjoyed this journey into the mysteries of the past, make sure you subscribe to History Hit for more stories that bring history to life.